let's get into a little bit more of understanding of what are the problems and challenges with traditional model of deploying Office 365. If you look into the portfolio of suite of Microsoft 365 applications, starting with Exchange Online, if you look at that particular application or service from Microsoft, oftentimes there are many long-lived connections, and there are up to 5 to 10 persistent connections, TCP connections from each user going out to these applications. When Microsoft few years ago moved from on-prem applications, especially Exchange, SharePoint, and other services, to a cloud-based SaaS application, they fundamentally did not change the underlying technology, how a client connects to an application. So all of that, mostly when they migrated or moved to a cloud, it is wrapped inside an SSL and made that sessions go out over internet to reach the Microsoft front doors. So from that standpoint, the fundamental capability of the product in terms of having number of persistent connections did not change. That means if you have a small branch office of 50 people, you are having around, on an average, let's say 10 into 100, you have 1000 persistent connections just to Exchange Online application alone. That means that would put an enormous stress on your firewalls and on-prem infrastructure in branch offices to enable local internet breakout. And coming to other applications like Teams. Teams is one of the popular applications used within the Microsoft M365 suite for collaboration and productivity purposes. And as you could clearly see, Microsoft Teams is a complex application which has both a control channel traffic, and you have a audio, video traffic, media traffic going through UDP plane. So when you have such a large complex set of protocols, there is a lot of information and insight which goes within the control channel, which is used to constantly provide the end user with the right media servers to go and have a better and secure access from a better user experience standpoint. If you have this control traffic going through an inefficient path of hub and spokes, it would result in a longer path. To understand the mechanics of why and how that path gets very much latency involved, go and look at our session on DNS, where we talked at length about how DNS plays a key role in providing a better and efficient Teams sessions and collaborative traffic for end users. Similarly, from a SharePoint and OneDrive perspective, as these connections are very persistent in nature and large amount of data movement is involved, it is often important to have a shortest and most secure path to Microsoft front doors. And how you architect your network is going to be very critical. Not only that, Microsoft applications use and rely a lot on updating their endpoints, with a lot of these updates coming from often related to Windows updates. And these updates are high frequent in nature, and there is a risk of consuming a lot of bandwidth without having a proper visibility and understanding of the bandwidth needs. It would end up in a situation where your users would starve for having a better application access. So on an average, these updates range from anywhere between 100 to 500 megabits per user. And if you think of that in some of the peak times, these applications are going through your network, would really starve the business critical applications.